This is lesson 12.2, graphing data. Our objectives for today are to identify which pieces of data are quantitative and which are categorical, to know several ways in which to organize data, and to recognize which organizational representation would be best for a particular set of data. So, when we're working with statistics, it's important to recognize different types of data. Most data fall into one of two groups: quantitative, which is numerical, and categorical. So quantitative data, I think of it as like, I remember it's number because quantitative, quantity, right? So it has to do with numbers. So these data pieces can be represented as a number or have meaning as a measurement. All right. So let's look at what kind of information would be considered quantitative data, like, anything that's numerical when you collect it. Like if you're asking a question like how many, how much, how big, how small, that kind of thing. Things where the answer to your question would be a number, right? So height, IQ, blood pressure, a count of something like the number of students not participating in online school or the number of deaths from COVID-19. So quantitative data then has two more forms, discrete and continuous. So think about like counting numbers versus like decimals and fractions, I don't know, kind of thing. Okay, so discrete data is like your counting numbers. Okay, so like your shoe size, number of people in line at Costco, number of people who've been laid off. Whereas continuous data could also include fractions and decimals, right? So we can't perfectly count them. So how much gas is in your gas tank, right? You're filling it up. You have 1 gallon, 1.1 gallons, 1.2, that kind of thing, right? Height, how many antibodies are in your blood, all right? So think of discrete and continuous as sort of like the counting numbers versus all real numbers, including fractions and decimals. All right, so let's see if we can identify what data is discrete or continuous, and we'll just put a D or a C. Okay, so number of people in Utah County with COVID-19, so that one's discrete. There's not half of a person, right? How many COVID-19 tests are available? Also discrete. How many antibodies are in the blood of someone who recovered from COVID-19? That one's going to be continuous. How much money the hospitals spend to buy protective masks for their workers? This one is also continuous, right? You have dollars and cents. All right. So what about categorical data? So these are things that are sorted or divided into different categories, right? So instead of like numbers or things that you count, we have categorical data. So for example, are you positive or negative for COVID-19, right? There are two possible answers to that question, and you have a category of positive and a category of negative. Type of music you listen to in quarantine, right? So that has categories, right? The answers would be categories: rock, classical, favorite quarantine hobby. Again, the answers would be categories. Okay, so hopefully this makes sense. Types of baked goods you made in quarantine, and your favorite teacher in online school, which only has one answer. Let's be realistic, right? Okay, so let's try identifying data as either quantitative or categorical. So basically, is it a number or is it a category, right? That's what we think about. Okay, so number of credits. So yeah, I gave it away because you say number of credits needed to graduate after skipping online classes. So it's quantitative because it's a number. Types of quarantine comfort food, categorical. Calories in quarantine comfort food, this time is going to be quantitative. Weight gain due to quarantine comfort food, also quantitative. All right, so now let's talk about the types of data representations. How do we organize our data into graphs, tables, or charts, right? So we have all these different things, and you've probably seen a lot of them before. Pie chart, bar graph, Venn diagram, right? A Venn diagram are those two circles, or sometimes three that intersect, right? A dot plot, that's when you graph individual data dots, right? A line graph is when you have like a line, like the stock market is often represented by a line graph. Scatter plot is similar to a dot plot. A two-way table, right? We saw those in the last unit. Stem and leaf plot. So a stem and leaf is when you list your categories down here, and then you have the number represented this way, right? And then a box and whisker plot looks like this, and we'll learn how to do those later in this unit. All right, so you can use almost any type of data representation you want, but some are better than others for certain types of data. For example, you can't use scatter plots, stem and leaf plots, or box and whisker plots to represent categorical data because they all require numerical data. So the best things for categorical are things like pie charts, bar graph, Venn diagrams, and two-way tables. The best things for quantitative or number data are scatter plots, stem and leaf plots, box and whisker plots, line graphs. And then pie charts and bar graphs can also be used with quantitative. You just have to put in like numerical intervals across the bottom of your graphs, right? Okay, so pie charts. It's a circle graph divided into slices based on the percentage. That means all the slices have to add up to 100%. All right, so here's an example. The chart to the left represents people's favorite quarantine hobby. Estimate the percentage of each color. All right, so if you're thinking about how much each one represents, so imagine like if you could cut this in half, that'd be like 50%, right? And if you went like this, that'd be like 25%. So it looks like eating cupcakes is a little bit more than 25%, right? So cupcakes, I don't know, we could estimate maybe like 27%, right? Now binging Netflix. So you can look at this and say, how close? That looks like it's a little bit wider than a 90-degree angle to me. Also a little bit more than 25%. So we could make Netflix also 27%. They look about the same to me. Okay, and then what about napping here? So if I look across, it looks like, about 50%. So if we wanted to do eating cupcakes plus binging Netflix plus napping, it looks like it takes up about 75% total of the circle, right? So if I add up my 27 plus 27, I've got 54, right? Whoops. And so then if you wanted it all to add up to 75, I could do 75 minus 54 and get that napping is about 21%. Excuse me. Now the last two together look like they take up about a quarter of the circle, and they look about equal in size. So if we wanted to do 25% for both of them together and divide it in half, 25% divided by 2 is 12.5. So we could say puzzles 12.5 and reading the news 12.5. So it's important that all your numbers add up to 100% when you're done with your pie chart, right? So these ones should add up to 100%. All right, let's try one. Sorry. So a survey was taken on people's favorite quarantine comfort food. Right, so pizza was 35%, fried chicken was 22%, cupcakes were 20%, 12% were brownies, and a certain amount didn't like comfort food. So we need to create a pie chart showing the data and also ask what percentage of insane people don't like comfort food, right? So let's do that part first. So I'm going to say in my calculator, how much is 35 plus 22 plus 20 plus 12? So I got 89%. So that means 100% minus the 89 means there's 11% that don't like comfort food. Okay, so let's draw our chart now. So we'll make a circle. Yep, we'll make a circle and then we'll say 35%. So if you imagine again, right? A quarter of the way would be like 25, but I want to make it 35, so we'll just make it a little bit bigger. And that's pizza. And then fried chicken is 22%. So 22 is a little bit less than a right angle. So if I imagine like making a right angle off of here and then make it just a little bit less, right? And then cupcakes are 20, 12 are brownies. So 12 plus the 11% that we calculated before. 12 plus 11 together makes 22%, right? So what we need to do now is divide this almost in half, right? I think, but one of them is a little bit bigger, so let's see. So we'll divide this in half pretty much. And then 12% and 11%, so divide it mostly in half again, right? So then we have cupcakes. Looks like I made my fried chicken line a little bit too small, so let's do that a little bit better. There we go. And then we have brownies, and then we have none. All right, so it's not perfect, right? But good enough. All right, next one, bar graph. Bar graphs are a graphical display of data using bars of different heights. So here's one I found in the news today that you can see. So our categories down here, we have ages, 0 to 19, 20 to 44, 45 to 54. Now I want you to notice, this is an example of statistics in the news that are misleading. Look at these categories here on the bar charts. 0 to 19. So that has 20 because 0 counts as 1. That has a 20 years of people in it, right? But 20 to 44, right? How many years is that? That's 24 years. 45 to 54 is like 9 years, right? 55 to 64. So these bars are not, it makes it look different than it actually is, if you can see that, right? So 65 to 74, 75. So they've done it okay up till then, and then greater than 85. It doesn't even say how high they went to, like 100. We don't know, right? Okay, so they made their groups for the bar charts unequal. And that means that the height of the bar chart is not actually what it really looks like, okay? So it's misleading. So knowing about this stuff is actually really important, right? When you see things in the news, see things in the media, and they're designed sometimes with bias, right? They're designed to thrill you or scare you or make you feel a certain way on purpose, and they will make the data represented in a way that they want, you know. But in reality, if you look closely at it, it's not accurate, right? All right. A survey was taken on people's primary COVID-19 symptoms. 16 people had a dry cough, 12 had a fever, 10 had a sore throat, 10 had upset stomach, and 4 had no symptoms. Let's create a bar graph, okay? So, when I create a bar graph, the first thing I do is look at the numbers I'm needing to look at. So the smallest one I have is 4, and the tallest I have is 16, right? So you can decide kind of what you want to count by. I noticed that they're all even numbers, so we could count by 2s, 2, 4, 6, right? 8, 10, 12, 14, 16, right? So decide on that, and next we're going to make categories. So we have cough, we have fever, we have sore throat, we have upset stomach, and we have no symptoms, right? Okay. So you have 16 people with a cough, so we draw our bar. 12 people with a fever, so draw the bar. 10 with a sore throat. and 10 with an upset stomach, and 4 have no symptoms at all. Okay? All right, central tendencies. There are 3 main measures of central tendency. So think about central as the middle. So central tendency are measures that describe the middle of the data, right? So that's important because the middle of the data is kind of where most people are falling, where most things are happening, right? Okay, and these are mean, median, and mode. So the mean is the average. Mean is the same thing as average, right? So you add up all the data and divide by how many data points you added, all right? So like if you wanted to find the average of the numbers 1 through 5, right? You'd add them up. And then you had 5 numbers, 1, 2, 3, 4, 5, so you divide it by 5. Add your data and divide by how many you had. The median is the physical middle, right? So what you do to find the median, you first have to put the data in order and then count to the middle. So let's say we had some data like 1, 1, 3, 7, 9, 10, 15. So it has to be in order, right? And then you find the actual physical middle, right? So count off and find the actual physical middle, 7, okay? There's 3 on this side, there's 3 on that side. If, for some reason, you have, right, 2 numbers in the middle, like let's say, okay? So let's say we counted it off. Oh, whoops, I didn't make one. Okay, we have to put one more number. There we go. So there's 3 on this side, 3 on this side, and there's 2 left in the middle. What you do is you take the average of the 2 left in the middle, and that's your median, okay? All right, mode is the number that occurs the most frequently, okay? And of course that's useful because it tells you what the most people had, right? What the most things that you were observing were. Okay, so the mode occurs the most. Mode, most. So like if you had a data set 1, 2, 7, 7, 9, 9, 9, 10, 10, 16. 9 would be the mode. Sometimes a data set can have more than one mode, like if there were also 3 sevens, 7 and 9 would both be the modes. And sometimes a data set can have no mode. If there are no repeated values at all, then there would be no mode. Okay? All right, so of course I have a song for you. Okay, this is my Measures of Central Tendency song, and it goes to the tune of 3 Blind Mice. All right? All right, so I've grabbed my ukulele and I'm going to sing you the Measures of Central Tendency song. Mean, median, mode. Mean, median, mode. Mode is the most. Median is the middle. The mean is the average, and so we add, divide by how many numbers we had. Mean, median, mode. I know you guys have missed my singing. All right, so stem and leaf plot. Before we calculate the mean, median, mode, so it makes sense to organize the data, a stem and leaf plot is nice because it helps us put the data in order, and you can easily see which data occurs the most, and you need things in order to be able to find the median. So let's try a stem and leaf plot. So here's some data. We're going to make a stem and leaf plot and then find the mean, median, and mode. All right, so basically you're just putting things in order, okay? So if you look at the data that we have, so I try to identify what's the smallest number and the largest number in the group. So I see the smallest number looks like 12 and the largest number looks like 20, right? So I can arrange it. Now this is going to look kind of funny, all right? So we want to do like 12 like this. And I like to cross things off as I put them into my stem and leaf plot, so I know where they go. So let's look and see. Do we have 13? Yeah. So it looks like there's 113. Now look for 14 and always check for any more. 1, 2 of them. All right, how about 15? 1, 2, 3, 4, 5, 6 of them, right? 1, 2, 3, 4, 5, 6. All right, how about 16? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to run out of room. 9. Oh no. Okay. 17s. 1, 2, 3. That's it. Okay. 17. How about 18s? So 1, 2, 3. Oh, and I see that I missed an 11. There was an 11. That was actually the smallest. So let's add that up here at the top. Oh, and a 10. I did a terrible job, huh? Okay. Okay, what next? Okay, so we did our 18s. All we have left is 119 and then 120. Okay. Good deal. Okay, so now you can see it's almost like a sideways bar graph, right? Like you can see it's almost like a sideways bar graph, and you can easily see how many. So we can easily see the mode is 16. Mode is the most, right? And then the median, you have to find the middle number. So if we go here and count off, right? So the other way you can do it is count up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. We have 29 data pieces. So if we divide 29 in half, we'll be able to find what the number in the middle is, right? So 29 divided in half is 14.5. So if we go now to the 14th and 15th data point, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 are here. So that means that our median is 16. All right, and then finally, to find the mean, we would have to type all that into the calculator, right? So 10 plus 11 plus 12, right, all the way up to the 20, and then we'd have to divide it by how many we have. We just counted up that we have 29. Divide it by 29. It's kind of time consuming, so I'm not going to do it, and I'm going to show you something really cool on your calculator that you can do. Okay, so you can actually do mean, median, and mode right on your calculator. Okay. All right, let's see. So here it goes. Okay, so on the calculator, you can insert in a set. This works on the Desmos graphing calculator. So go into ABC and enter 12, right? So I'm entering in all this data now. So I'm typing in the whole data from the last problem. Okay. And you put a comma in between each one. All right, yeah, when I did it before, I missed one. There were actually 30 broad numbers in the problem, but yeah. So it'll tell you 30 elements, so you can make sure you didn't miss one. Now here in the functions button, there's a stats right here. See that? And you've got mean and you've got median. The only one it doesn't have is mode. You have to figure out mode on your own. You also have stuff like total if you needed to sum all your numbers. There's all kinds of cool stuff in here. Min, max, whatever. So now I just say, tell me what the mean of A is. 15.7. Pretty nice, right? Now I say, tell me what the median of A is. 16. All right? So this is pretty cool. The calculator will do it for you. All right. So the next thing that we like to look at when we're trying to analyze our data is the 5-number summary. So we look at 5 different numbers, the minimum or the lowest value, the maximum, the highest value, the first quartile, second quartile, and third quartile. Second quartile is the same thing as the median. So basically we're kind of dividing the data into 4 pieces, right? With the 5-number summary. Okay. And we represent the 5-number summary with a box and whisker graph. Okay. So if you look at this, you can see down here, this is like your minimum right here at the end of the box. And right here, we put our first quartile. Right here, this is where our median or second quartile goes. Here's our upper quartile, and then we have our maximum right there. So the box and whisker is cool because it can kind of show you how the data is distributed, right? If you have the most of it kind of near the top or the most of it kind of near the bottom, if it's pretty equal, it's actually really neat. Okay, so let's try this. Given the data set below, find the central tendencies, 5-number summary, and make a box and whisker plot. The data represents scores out of 36 points on the last test. So here's a bunch of data right here. All right, so we're going to do this on the calculator. Okay, so I'm going to type A equals, and I'm going to type in all that data. Make sure that you use the hard brackets here around the data that's under the ABC button. Okay, so we just got to type in all the data. You want to really make sure you don't make a typo here. That would be terrible, right? So really make sure you're careful. And then also count up how many elements you're supposed to have. There are 25, and see, it verifies I've done 25. All right, so let's get 5-number summary now. All right, so I want to know what the minimum is. There we go. And I also need to know, see the button quartile? You need to know the first quartile. So what you do is you say, out of set A, I want the first quartile. So that's 27. Next, we need the median in the middle, also known as quartile 2. So if you typed in quartile A2, you'd get the same answer. Next, we need the third quartile. All right. And then finally, we need to know what the maximum is, right? All right, and there is our 5-number summary. You can see all 5 numbers. Okay, now this is really cool. So if you go in here and go up to distributions, you will see right here box plot. That's a box and whisker. So we tell it to box plot A for us. Now you might not be able to see it on your graph because it's going to depend on where the data is. You can click this zoom fit, and also you can drag the graph, the screen over. Right, our data was all like the minimum was 23 and the maximum was 36, so you have to scroll over to that to see it. And here's our box plot. So look, isn't that pretty cool? All right, so remember when you're graphing data, don't forget to give the graph a title, label it properly, make the graph look nice. And always remember, don't overbake your quarantine brownies.